All right. So, my name's Brandon, and this is
I'm Jordan.
This is Jordan, and this is the DeepThoughts Podcast, and we basically are going to talk about science and math and music, AI, that sort of stuff.
All sorts of fun stuff, computer science, all sorts of. It's all cool. Can't wait to talk about it.
Yep. Very interesting. So what are we going to talk about today?
We're going to talk about how humanity is kind of witnessing this intelligence explosion or this rapid technological advancement. And I think that's a pretty interesting thing to talk about because I feel like we can kind of predict how it's going to go, but we can never predict the future, so I guess we'll just talk about it for a second here.
Yeah, so we'll kind of delve into that. So what you're saying there's some quick advancement of technology, right?
Yeah.
So
you got that right. Right. Glad you like that.
So when you gave me the thought, you explained that advancing technology is similar to like a logarithmic function and how things are coming about.
Yeah, logarithmic is actually the mathematically correct way to, probably the mathematically correct way to analyze it, because of the pattern that we can kind of observe in how the world has changed over the last few thousand years. So it all started with basic counting. So obviously, we were able to count for thousands and thousands of years, however long we've been here. We've been able to count. But then at some point, I don't know the exact date, or years, or the year of BC or whatever. Like maybe it's 325 BC or whatever. They invented algebra, right? So algebra came about, and then about 1,000 years after that, maybe 1,200 or 1,400 years after that, calculus was invented. 1600, so let's say about almost 2,000 years after that. So then after calculus, about 200 years after that, we saw the Industrial Revolution. And this is not even to mention the Renaissance era, of course, this is all that too. About the 1400s, I think, if I'm not mistaken. And after the Industrial Revolution, it was 200 years from calculus to the Industrial Revolution that we then saw about, what would that be? About 150-ish years to see because the Industrial Revolution was like the advent of electricity and stuff like that. So we started using electricity for all sorts of stuff. And that of course changed the world, right? And then the next thing that we kind of invented that hugely changed the world was computers. There's all sorts of other world-changing inventions that are happening along the way, but I'm kind of thinking from like a very scientific, like knowledge-based perspective. Like computers is like the next biggest thing that happened. And so that took about 150-ish years to see the beginnings of computers, calculators, and things like that. And that of course stemmed from electricity. So then from computers, about 40 years after that, we started, or maybe 30 years after that, we started seeing the invention of AI. It didn't change the world yet, but AI was kind of starting to be born. And about 20 years after, or 20 or 30 years after its first sort of conception, it really, Google it released these sort of like algorithms and procedures to really drive AI forward and change the world with that. And then, so that kind of leads us to today, right? Today we're seeing the effects, the very newborn effects of AI changing the world. We've already seen how computers are changing the world for the most part, and we've definitely seen how calculus has changed the world. We've seen how algebra has changed the world. But the main point here is that that's about 1,000 years to like 200 years to about 100 something years, and then like 50 odd years. And if we extrapolate that pattern, we can expect, this doesn't mean it's going to happen like this, but if we follow the data, follow the observation, extrapolate from that pattern, we can expect that probably the next world-changing invention or whatever will be within the next 25 years, approximately. Just because it seems like it's like 1,000 to to 200. That's so you can see how that pattern kind of emerges from that.
So in essence, you're saying that basically each technological advancement that's happened in our life, or not in our lifetime, but in the lifetime of our universe or whatever.
Sure.
Each technological advancement that's happened has got progressively quicker in where it's happened in time. Like we started with fire, then we moved to the next technology, but that took a large chunk of time to get to that point. And then, but the next thing after that took lesser time. And that's probably because we had these tools at our disposal.
Yes. So I want to mention how you can tie it to something in mathematics specifically. So it's where if you have these chaotic systems, if you define some kind of dynamical system, we can talk about this in another video specifically, but if you're simulating this sort of dynamical system where you've got all these numbers changing and stuff, like you're looking at a simulation essentially, you could have these simple rules, and each new little simple rule you add could kind of cause turbulence in it, and that's what we would call chaos. And the general sort of consequence of doing that is that it will accelerate into chaos. So it might start with small little local reactions. Like imagine looking at a particle simulation. I don't know if that's the best example, but a particle simulation is a dynamical system. It's an example of one. And you could see as you imagine waving your hand through the particles, like you're looking at water or something and you put coloring in the water to see how the fluid is moving. Then you could see a large sort of wave or something, or like a trail of where you move your hand, but then you'll see these little offshoots of little whirlpools, or whatever you call them, little spirally ones, and so they just kind of go off and do their own thing. And so that's the turbulence of that simulation. And but the idea is that they could be going off and doing their own little thing, and then eventually something else will come out of it too that you would not really predict. You couldn't really predict it because it's a chaotic system. So that said, we can tie this idea of our intelligence explosion as of today to this acceleration of a chaotic system. So I specifically want to say that it's in our reality to be simulated, right? Like we can use math to compute what the future of some simulation will be, right? And that pretty much parallels our reality, right? So being simulated is like our reality. Even if it's not true that we're in a simulation or something like that, that's a whole theory on its own. But we can't deny that we have these mathematical models that describe our progression through our reality using physics and cellular automata and all sorts of things like that, which we can talk about in another video. So that said, because it's like we're being simulated, because we can draw parallels between being simulated and what we're observing in real life, we can expect that probably we are also subject to the laws of chaotic simulation, like long-term chaotic simulation. It means we can't predict the future until we go through it and get to the future. So, like with the little whirlpools, after you just wave your hand through water and you see the little whirlpools that go off and do their own thing out there in the other parts of the water. So you can't really predict where they'll go.
It's like wee.
Except for in the local time scale, in just a short period of time, you can predict where it's going. But if you say, where will it be in 1 minute, in 60 seconds, then it's probably going to be gone, but you don't know. Maybe something else will come from it and it'll just keep spinning.
It might start making its own whirlpools, right?
Or something. So, I mean, you can test this at home. Just fill up your sink or bathtub or wherever, and just start waving your hand through it and just look at how the water moves. And if you really want to go the extra mile to see how it looks, you put some like food coloring or not food coloring, whatever it's called, just some coloring in the liquid so you can see see what the motion is like. And so that's a very fascinating subject. So
basically, we can assume that technological advancements in the future are going to come quicker than they have in the past, in a way.
Yeah, it's
potentially.
The main point would be that it's building on itself, and because it's building on itself, we don't know how to predict how it's going to change until it actually changes and comes. Long story short, I'm saying that within the next 25 years, as I described earlier, we're probably seeing the next huge world-changing invention, whatever it is. We don't know what it is, but it's probably coming because that's what this chaotic system of ours is suggesting is going to happen. So, yeah.
Good or bad, right?
It could be good or bad. We don't know. We just don't know. So, hunker down.
Hunker down. Get a bunker.
Get a bunker. Yeah.
What was the paradox that you related this to?
It's Zeno's paradox.
Zeno's paradox.
It's very similar, like that halving of time, or however you want to think of that. It's like, from the thousands of years to 200 plus or whatever, and then 50 and then 25. That's like a halving of the time period, like the intervals between, world-changing inventions. And so that halving is, you can draw another parallel between that and Zeno's paradox. And for those who don't know what Zeno's paradox is, that is where I think the original analogy was Zeno himself, whoever he is. He shot an arrow. He had a bow and shot the arrow at a target, and that arrow it'll travel halfway to the target, right? And then it'll travel another half of its distance remaining, and then it'll travel another half and another half and another half. And the idea with the paradox is that if you always have to go halfway to your target, you're never going to get there. So, yeah. But the arrow reaches its target anyway, so it's kind of a paradox. How does that happen? So obviously we can describe that with, of course, a dynamical system to show that of course it reaches its target, but theoretically, or like from a conceptual level, it's like it has to go halfway the distance. So it should never ever get there because it's asymptotic. So you can relate that then to what we see in our technological advancements and our explosion of intelligence, in the way that we may not ever get to an instantaneous sort of changing of the world, right? There will be there's an asymptote that we're probably reaching where it's the fully chaotic development of our reality, at least on our little blue marble in space. Yeah. So yeah, that's yeah.
We should probably let's tie it into an ending here for so what in summary what is the main point of all of this?
It might be a little scary to think of it, but I mean, there's nothing we can do about it because it's probably happening. I mean, there's a chance that it won't even happen. Like maybe that's not what it is. Maybe we'll go 200 years before the next huge world-changing invention happens. Yeah. I mean, so that would just debunk the whole theory there. But and it's possible that that's what will happen. But it seems like the math is pointing to it being fully chaotic within the next 50 years. So
yeah.
So, but don't be scared. It's just, I mean, we'll all survive.
Yeah.
So hopefully.
But
yeah.
Yep.
Cool. So yeah, that's what was it?
Yeah, that's the Deep Thought Podcast.
Oh yeah, that's what we're doing.